All right, in this video, I'm going to go over the uh, the practice problems for test one, chapter 3, section 8. Okay, so yeah, this is where I left off the last time. So see, here is question: the number of flows in bolt of cloth in textile manufacturing is assumed to be Poisson distributed with a mean of 0.08 flow per square meter. So question A, what is the probability that there are two flows in 1 square meter of cloth? So the first one, you need to use the PAMF, probability mass function of Poisson distribution. Okay, so let's see. All right, so now see the PMF of a Poisson distribution is this. Okay, so now second. So f of x is equal to e to negative lambda t times lambda t to the x power over x factorial. So t is the timing number, or just the finite the length. Okay, so the lambda is the average number of flow or success. Okay, per the unit, maybe per millimeter or meter. Okay, for hour could be. So the x is the total number of successes or flows in t. Okay, so that's the total, the number of flows or success. Okay, um, in t. So now question A. Okay, so we need to figure out all the parameters, right? Lambda and t and x to figure out the probability. Okay, so the question A says that what is the probability that there are two flows? It means that x in 1 square meter of cloth. So question A, t gonna be 1 square meter, right? 1 square meter, and then lambda is the given in the in the problem, which is 0.08, right? 0.08. Okay. So now then x is gonna be 2, right? Okay. X is two flows. So we need to figure out probability that x equals 2, right? So this is equal to f of 2. That's gonna be e to the negative 0.08 times lambda t, which is 0.08 to the second power, right, over 2 factorial. Okay. And then what about question B? What is the probability that there is one flow in 10 square meter of cloth? So then it means that 10t time t going to be not here time t, but the length. I mean, in this case, area, right? Area is going to be 10 square meter. So the lambda is still 0.08. Okay. And then x is the 1, right? 1 flow. So then probability that x equals 2, that's what we need to figure out. This is f of 1, which is 10, I mean e to the, because e to the negative 0.08 times 0.08, oh, times 10, right? Times 10 to the first power over 1 factorial. Now then, let me see. Next problem, let me do it here. Okay. So C. Okay, what is the probability that there are no flows in 20 square meter of cloth? Okay. So now then, give me a second. The first one, T gonna be say. So now, let's see. So here T is 20 square meter, right? Square meter. Lambda is still 0.08, right? And then x gonna be 0. Okay. So this, I think, because of, I mean, that makes problem much easier. So probability that x equals 0, it's gonna be f of 0, right? So this is equal to e to d negative 0.08 times 20, right? Okay. And then lambda t to the x power. But you see that here, if x equals 0, then that term becomes 1, right? So we don't have to mention that over 0 factorial. Remember that 0 factorial is 1. Okay, keep in mind this. So you just calculate this one. Okay. So I told you because of this, I told you that makes problem much easier, right? So you just calculate that exponential number. Okay. And then D. What is the probability that there are at least two floors? Okay. In 10 square meter up close. Then yeah. So at least two, right? So we need to figure out the probability. Oops. We need to figure out T lambda, right? T is 10 square meters and lambda is 0.08, right? So the probability that x is greater than or equals to because of n least. But this is equal to what? 1 minus probability that x is less than or equals 1, right? Okay. So now then this is equal to what? 1 minus e to the negative lambda t, t is a 10, and then lambda t 0.08 times 10 to the, sorry, it's out of space, to the first power over 1 factorial, right? Let's just calculate this one. Okay. All right. So that's the how to figure out the probability of the Poisson distribution. But you can calculate. There is other way to figure out probability of Poisson distribution using using calculator. Okay. So we go to the distribution, press second, and then variables. Then you see that right there, Poisson CDF, Poisson PDF, right? Okay. So let's the for example, problem A. When you want to figure out probability x equals 2, there are two floors in one square meter of cloth. Then we use a Poisson PDF. If you want to figure out the probability x is greater than or equals 2, see, so that the using the rule for complement, you got this 1 minus probability x equals less than 1. See that probability x is less than or equals a whole number, that we gotta use Poisson CDF, which is cumulative. Okay, so now then let me use a Poisson PDF to figure out let's see A. Okay, so in using the Poisson PDF, so lambda is a 0.08 and the x value is 2, right? 2. Okay, we got the 0.0029. Okay, and then let's see problem B. Okay, so you may catch that when you use a calculator to figure out the probability of Poisson distribution, in this calculator, uh, it assumed that the length or time interval is just, or area is just the set to 1. Okay, but you look at the problem B, t equals 10, right? Then we gonna we need then t equals 10, but as you can see that here, this distribution, when you go to the Poisson PDF or CTAB, which is the same thing, but the oops, give me a second. Poisson PDF. Okay, so there is no there's no input for t, right? So now, because the calculator, I told the calculator assume that t equals 1, then how can he figure out the probability for that kind of problems, which is t is not equal to 1? Then we need to figure out the average number of successes in not 1 but 10. Okay, because the lambda is 0.08. That's the average number of successes per the unit in this problem, unit square meter, right? Which is 1 square meter. Then what's the average number of successes per 10 square meter? 0.08 times 10, right? So lambda going to be 0.08 times 10. Okay, and then x value is here 1, right? So 1, and then we paste. Okay, So we got the 0.359, approximately 5, okay? 0.3595. So this is how to use calculator to solve the Poisson Poisson distribution problems alternatively. Okay, so let's move to the next problem. All right, in this problem, let's see. Let's take a look at the question. The number of content changes to a website follows a Poisson distribution with a mean of 0.45 per day. So question A: what is the probability of 2 or more changes in a day? So definitely lambda is 0.435, right? So here the unit is means 1 day. Okay, so lambda is 0.45. And then question A, the t must be 1, right? Okay, and then x is, question A. Let's see. Let's figure out solution in a sketch paper. So question A. So we need to figure out the. Let me mention the t. T is 1, right? Means that 1 day. Okay, and the lambda is a 0.45. Okay, here x is the 2 or more changes, right? So x must be greater than or equals 2, right? So we need to figure out probability that x is greater than or equals 2. Okay, then what? This is equal to what? We need to figure out what? We need to rewrite that probability as 1 minus probability that x is less than or equals 1, right? Okay, so that's the what? Poisson CDF. Okay, cumulative cumulative mass functions kind of. Okay, so now this is equal to 1 minus, right, f of 0 plus f of 1. Okay, so f of 0 is what? E to the, using the formula right here, we've seen that. Okay, this one. Okay, just plug in 0 into f and plug in 1 into f. Okay, because lambda and t are already figured out, right? So, but let me use calculator to figure out probability that x is greater than or equals 2 using a Poisson CDF in the calculator. Okay, so right there, we go to the distribution. Okay, second. Okay, so now then we go to the we use Poisson CDF. Okay, why we use CDF? Because CDF probability x is less than or equals 1. So I'm gonna figure out this probability using calculator and then subtract that number from 1. Okay, so right there, so lambda is what, 0.45. I told you, make sure that to use the that function, interest function Poisson CDF PDF in calculator, the make sure that this calculator assume that t is 1. Okay, so now 0.45, and then x value is, see, 1, not 2. Okay, it's 1. So we got see that 0.2954560 approximately, and then we subtract the number from 1. So 1 minus the number. Okay, so we got 0.0754 approximately. Okay, question B. In question B, let's see. The question is this: what is the probability of node content changes in 5 days? So t equals 5, right? So question B, t equals 5, right? The lambda is 0.45, right? And then the question is to find out probability x equals 0 because no contents. Okay, so that's going to be what? So e to the, if x equals 0, we haven't seen that, right? If the random variable value of random variable 0 in previous problem 0, denominator, lambda to the lambda times t to the x power. Okay, lambda t to the x power over x factorial, that fraction gonna be 1, because the lambda times t to the 0 power is 1 over 0 factorial is 1, so 1 over 1 is 1. So e to the negative lambda t gonna be left. So So here, keep in mind this. What? F of 0 is what? E to the negative lambda t. Keep in mind this. So the problem, this is going to be what? E to the negative lambda t. Okay, because we know t and then we know lambda, so plug them into this formula, you can get the answer, right? Then problem C, what is the probability of 2 or fewer changes in 5 days? Yeah, so this is going to be a cumulative mass function, right? So we need to figure out probability that x is less than or equals 2, right? Okay. Oh, we need to figure out t, right? T is what? In 5 days, so t must be 5, right? Okay, time for lambda is 0.45, right, per day. Okay, so now let me use what? The Poisson CDF in calculator. Okay, so what I'm gonna do, we go to the we use the interest function Poisson CDF. Okay, so keep in mind this here, lambda is not 0.45, okay, because t is a 5. So we need to figure out the average number of contents in 5 days, which is 0.45 times 5. Okay, and the x value is 2. So we got the 0.6093 approximately. Okay. Let's see the last problem. Orders arrive at a website according to a Poisson process with a mean of 13 per hour. Determine the following. So here, the unit, the measurement kind of is an hour, right? So keep in mind this. So here, lambda is 13 per hour. Okay. So now question A, probability of no orders in 5 minutes. Is it 5 minutes, not 5 hours? So we need to figure out the what? Lambda, we need to figure out t first. T gonna be not an hour, but we need to convert the unit 5 minute to hour, okay? 5 minutes is what? 5 over 60 hours, right? So t gonna be not just 5, but 5 over 60 hours, okay? So, all right, so let me continue solving that problem in sketch paper. So here, okay, so question A, so t is what? 5 over 60 hours, okay? And lambda is still what? 13 per hour, right? Okay, so now then probably no orders, yeah, so means the probability x equals 0, right? So that means f of 0, we need to evaluate f of 0, which is what? E to the negative lambda t, I told you, okay? And then B, probability of 3 or more orders in 5 minutes. It means the probability that x is greater than or equals 3, right? Okay, so that is equal to probability that 1 minus probability that x is less than or equals 2. Okay, so we can figure out this one using calculator, right? So let me skip finding that probability using calculator because I did cover a lot. So now C, length of a time interval such that the probability of no orders in an interval of this length is 0.001. Okay, so the question asks you to figure out the time. Time, right? The such that the probability is 0.001. Okay, so t, that's the unknown. Okay, lambda is what? 13 raised 2. Okay, so x is what? 0, right? X equals 0 because the length of a time interval such that the probability of no orders. No orders means that x equals 0 because x represents a number of orders in time interval. So now the f of 0 we need to figure out, right? Because this is probably x equals 0, right? Okay, f of 0 is e to the negative lambda t, which is what? E to the negative 13 times t must be 0.001. We need to figure out the time such that that probability turns out to be 0.001. So we solve that equation for t. Okay. So now then what? we take a natural log, okay? Natural log e to the negative 13t is equal to natural log 0.001. Okay, all right. So now then, negative 13t natural log e is equal to natural log 0.001. Because natural log e is 1, right? So t is equal to what? Natural log 0.001 divided by negative 13. Okay. So approximately this is the 0.531 hour. Okay, keep in mind this is the unit is hour. Okay. So 0.531 hours approximately that is 31.86 minutes. Okay. Divide this. Right. So that's the practice problems in chapter 3.8. Okay. So I hope you earn the good score in the test one. All right. So yeah, just good luck, but for not that you need it.